My eyes are bigger than my stomach.
All right, everybody, we're going to get started.
And those are for me?
You guys can hear me? Could I have everybody's attention, please? All right. Hello, everybody.
Hello.
Welcome to the Pep Pioneers November Luncheon. Do you believe it? We're meeting in person again, and the crowd's gotten a little bit bigger. And we have an outstanding speaker today, and that's why we have such a big crowd. Dr. Bill Stringer, he's also our medical director at Little Company of Mary for the Pep Pioneers. He's a friend of mine, he's a friend of all of us, and he's a terrific guy. He's going to speak in just a minute, but I wanted to fill you in on a couple things. One, if you are interested in participating in a clinical trial, and many of us in this room have done clinical trials over at Bill's facility, I highly recommend it. It's a wonderful experience. You are helping others that are suffering from our disease, and it's just a great staff over there. It's easy parking, and it's a wonderful thing. So if you're interested in participating in a clinical trial, you can give me your number, you can give Dr. Stringer's number when he walks out, but he's going to be kind of in a rush to do that. We also have some great raffle prizes today that we're going to get into after Dr. Stringer's speech, okay? And that's when you're going to have your second or third helpings, okay, and the dessert, okay? But before I go any further, I got to thank our board of directors, because this board of directors is a group that has kept PEP alive during COVID. They're the ones that have written and produced Pep Talk. They're the ones that organize the callers, that call you and remind you that you're supposed to come to a luncheon. They're the ones that keep our database up to date. They're the ones that take care of our website. This group of volunteers, and they put together this whole great luncheon, including all these great decorations and the chocolates. They're doing it all for you. So we are so glad to serve the membership. And we're hoping the attendance will grow and grow, and we can grow out of this little room and maybe get the big room next door, okay? So without any further ado, I want to introduce Dr. Stringer because it's more important for you to hear from him than from hear from me. So I'm going to turn it over to Dr. Stringer, but I'd like to have a big pep welcome for him.
Thank you for inviting me. I'm going to talk a little bit about some of the stuff. I went to medical school in the 80s. All this stuff has come out since the year 2000. So if you haven't been in school lately, you probably missed all this. So I'm going to introduce two things. One of them is like, what have I learned as a doctor over the years? So it actually all started when I was in med school. I was involved with a surgery. The patient was anesthetized. There were drapes all around the patient.
Bill, a little bit louder. Keep the mic closer.
Closer. The patient was in surgery. The abdomen was open. It was a bowel resection. And I got to thinking about it. You know, you really can't tell what race or what culture or what this person is. I mean, you're just looking at organs inside, which means that you know, it started me thinking about how much we have talked about race in the last couple of years, and obviously it's a derisive thing. And so I want to talk about it in a positive fashion and get you to think about some things that have come up through the Human Genome Project that are really quite interesting. So the second thought is, you guys haven't really thought about it, but every one of you in this room is related to each other. Now, I'm not talking about a couple generations back, I'm talking about a long ways back. But I think that what you should know at the end of this talk is there's really not a lot of difference between us. Nobody's running around here with 3 eyes or 5 or 10 toes on one side, etc. So we're all really part of a race, and that race is the human race. But I'm going to try to convince you of that. Anyway, so let's see if I can get this to advance. Okay, so I'm going to talk a little bit about genes, and genes can be a complicated topic, but I'm going to make it as easy as what I understand, because I don't consider myself a geneticist. We're going to talk about mitochondrial DNA and Y chromosomes. Then we're going to talk about the way that those genes now interact with what we call paleoanthropology. So essentially going to sites around the world excavating. The next one is language and its complexity, the effect of weather on these early origins. And I'm going to talk about early art, which I think you'll find interesting, if difficult to understand. So, as I mentioned, the last 20 years, what you may or may not remember from your biology class is that you have these little things called mitochondria that are in your cells that actually generate energy. They were probably free swimming at some point, and we took them over and started to create energy inside of our own cells. They also have their own DNA. That's why they probably were originally a free swimming bacteria. We probably took them up, but they have DNA inside of them that we can actually trace. You get your mitochondria from your mother, not your father, and so mitochondrial DNA traces every mother all the way up the line in your family. So for the guys, we have the Y chromosome. So women are XX on this 23rd pair. Men are XY, and that Y chromosome traces every male ancestor that you've had all the way back. Okay, so that's the thing that's come up in the last 20 years. There's areas of these that, as they're being replicated, errors occur. Errors occur over a certain period of time, and they occur fairly regularly. And so you can actually trace DNA from different people by these errors, and they're called SNPs, or single nucleotide polymorphisms. I'm not going to get too much into it, but if you remember AC and TG, those are the components of DNA. It means that they switch one of those base pairs. Okay, so the Human Genome Project, you guys all paid for it. The first human genome was sequenced in about 2001 and released about 2003. What they did was they took individual portions of your whole DNA, and it would be sort of like taking every 200 yards and sticking them together from here to New York. Okay? So it was a tremendously arduous process. And then the machines got better, the machines got cheaper, and you can do it now for about $100. And how many of you folks have actually sent your DNA to have it checked? Okay, quite a bit. All right. So you'll find this even more fascinating. And some of you others may do this over time. Dad!
23andMe!
Yeah, exactly.
I love it.
Very well.
You are the
Yes,
one.
ma'am.
I said I did 23andMe. I love it. At the
Okay.
beginning.
So any of these are fine. Doesn't matter. I'm not affiliated with any of them, but they all do it. It's just a cheek swab. There's the cost going down from about $1 billion down to where we are now. So this is what I want you to think about. Every human being on Earth is related to an Adam and an Eve that were in Africa. Okay? What they did was they came out across this lower area. See all these? There's one line that comes out of there. It comes out into Southeast Asia, and then from Southeast Asia into Northern Asia, and back into Europe. And the reason that there was these different migrations was related to weather and obviously the resources and other things that were out there. So there's a mitochondrial Eve and there's a mitochondrial Adam. That doesn't mean that it sort of reinforces the biblical story. What it means is that there's a single person at the very trunk of the tree and everybody else is on the branches of the tree. Okay? So we have just figured this out in the last literally 20 years. And if you look at migration patterns, these are the migration patterns that came into Northern and South America probably about 10 to 15,000 years ago. So that's a much more recent development, Native Americans in that area. And interestingly, they're a very high percentage of type O blood. So if you see type O blood, it usually has Native American ancestry. So in this area I'm just talking about is the original, what was the question? No. This area, this is the Y chromosome pattern spreading throughout the world, and those small mutations show up, and this is the maternal DNA coming out of that same area into all different areas of the United States, Central and South America, etc. All right, so this happens to be mine. This is the Eurasian atom, or the Y chromosome atom. up here into the Middle East, into the Caucasus up here. It's part of where we get the word Caucasian. And then into Europe. And there was 3 spreads in Europe of this M343. One went to England, that happens to be where my family's from, Spain or Northern Italy. So all 3 of those have those mutations. So how did they get this? They went to different areas, they dug up DNA, they sequenced it, and they looked for these mutations. So the earliest mutation they can find is right here. And everybody in the world has this mutation that we know of. And this movement out of Africa was probably 80 to 120 people. That's how close we were to extinction. 80 to 120 people. And we're talking about 80 to 100,000 years ago. Okay? So this happens to be my mitochondrial DNA, which I inherited from my mom. So there's the Eve down there tracking in through the Middle East and up into Europe. It's not as finely divided at this point. There's not as much mitochondrial DNA, because mitochondrial DNA is actually much more fragile. But, so you've probably heard about the National Geographic Genome Project. These are the ways that they go into these different areas, dig up bones. Teeth actually turn out to be one of the best places to find preserved DNA. This is kind of hard to see, but this is most recent, all the way back to 6 or 7 million years ago. And we're Homo sapiens. We were competing with Homo Neanderthals, and then there's Denishians and Florentians. Florentians are what they call the very small people that were in East Asia. So there's mixtures of those DNA now. So if you look at just the skull type, this is a normal human skull type now, and look at further back here, multiple years, 2 to 3 million years, the brain case has actually gotten bigger. The face has actually become much more vertical. Actually, the chewing mechanism has actually changed. It's more of a chewing than a biting mechanism. It also has molars as well as incisors. And actually, there's different teeth that are related to different groups on Earth. And that's another way to separate them. I'm not a dentist, so I'm not going to get into that. But there's also admixtures of other Neanderthal or Denishian DNA, and there's actually other ancient DNA we haven't identified yet. So all the people in the room here, about 2% of you is Neanderthal. Now, it's fascinating what the 2% is. The 2% has to do with skin color, and the 2% has to do with immunity. So the interesting part about that is as the Neanderthals went into the northern climes, they had to have lighter skin in order to get enough vitamin D, because you get vitamin D from sunlight. So as you came out of the areas of the earth that have more sunlight, you needed to change the color of the skin, and that's one of the things that comes out of the Neanderthals. The second thing is the Denishians are over here. That's the immunity part of it. And they have been living in this area for probably 50 to 100,000 years before humans showed up. And there's definitely interbreeding, and the interbreeding seems to have been preserved primarily in the immunology area, i.e. protecting them from pathogens that were in that area. So that was kind of the selective advantage of either skin color or immunity with these other groups. It's like something's going off over there. Is there a time over?
No. It's a different timer.
These are ethnic groups that you can sort of group things on. It's not my favorite, but it is a way to do it. I think that you should focus down here and look at all those children. They're just beautiful children from all different areas of the world. And, you know, they're children, right? I mean, yes, we can discern there's different hair colors, different skin colors, but they're really children. They want to learn, they want to grow, develop, have good lives, etc. So the way I think to think about this is that we really are more related to each other than we know, and that we make a big deal about things that really aren't such a big deal, and I think we forget about all the things that are the same between us, including our DNA record, which is now, like I said, in the last 20 years come up. This is another thing I thought you'd find interesting. So you guys have all been in the hospital, or hopefully not, but in healthcare someplace, and they're putting all this stuff in electronic medical records, right? So now there's a group that's taking a research trial, and basically they're asking you for your DNA when you go into the hospital. They sequence it, and then they actually look at what types of diseases you have and how that correlates with your genes. So this is called the eMERGE network, and you hear about it. I'm not going to talk about it too much here, but that's the type of genetic research that's going to emerge in the future that will help to inform us about risk for certain diseases. Okay, so that was genetics. Language. Language is another thing that is different throughout the world, and it's a wonderful difference as far as I can tell. I speak some Spanish and English, obviously, but I don't speak 10 languages. Almost nobody does, but you learn the first language on your mother and your father's knee, right? That's what you learn. It's not a written language when you start. Eventually you're taught in school. You're taught about, structure and grammar and subject, verb, object. But that's not the way you learn as a child. And the other area that seems to show up that's related to Neanderthals versus non-Neanderthals is Homo sapiens have an area that never shows up any other group, Neanderthals, etc. And that area is in language acquisition. We seem to have a unique ability to acquire language. And you've all probably got children and grandchildren. You've seen this, that they acquire language in their first year, a few words, then they start putting sentences together. And then if you've ever tried to learn a language when you're 30 or 40 years old, it's very difficult. And it's very difficult to get away from having an accent. So the first language you learn, and the language you learn before you're about 13 or 14 years old, before you go into puberty, that's when you're going to have speaking like a native.
Is it on?
I'm not sure what I'm doing wrong. Okay, well, it stopped, so I'll keep going for now. So anyway, one of the ways to tell how old a language is how complex it is. Okay? So where do you think the most complex language is in the world? I mean, all languages are complex, but there's different degrees of complexity. England?
Russia.
English? No, I'm talking about where in the world. Asia? Okay, because remember, the longer time you have to do it, the more complex it gets. So where's the oldest DNA? It's in Africa, yeah. And the oldest, most complex language is actually in Africa. And have you ever heard of a click language? Yeah, so apparently clicks are the most difficult thing to master, separate from tones, which is very common in Chinese, other languages. So clicks are isolated down in this area, and actually no place else in the world. Maybe I'm just going to talk.
Shut it off, Bill, and try talking.
Okay, let me just talk loud, and that's super annoying sound. So this area is where the most complex languages are these days. So if you look at what's different, every one of you in this room is unique, right? And you know that from your experiences in life, your medical history, your ancestors, your children. Every one of you is unique. But what makes us unique shouldn't be race. What should be is these other things: language, location, culture, religion. Those are all things that add, sort of a wonderful complexity to us. But we've anchored so much on race when race really isn't something that we should have anchored on. So anyway, so modern humans are genetically identical to ancient humans, and in fact we're related all the way back using our DNA. Same thing's true of the language story. Now, so I think some of you know I'm fascinated by art. I'm no good at it, but I'm fascinated by it. One of the things that got me really interested lately is there was a cave that was discovered in France called Chabet Cave. It was only discovered in 1995. So most of these other caves have been ransacked. Children and other people have been in there. This is really just a pristine cave, and it's a wonderfully gorgeous cave. And so I got thinking about these symbols. So this rock is what they call ochre. ochre is kind of that red stone, and it's what they use to actually color a lot of the caves. But this stone was in southern Africa. It's dated at least 100,000 years old, maybe actually higher. But you can see that there's what we would call today on the internet a hashtag. And it's these cross markings on here. This is not random. This is not random. This is high cognitive output for something. We have no idea what it was, whether it was keeping track of people, transactions, taxes, who knows. But there it is. So that got me thinking about this. This is also down in the Lowell Cave, probably 70,000 years old. It's a little harder to see, but the ochre there is also in a hashtag distribution. So you sort of wonder if maybe that had some kind of religious output or something like that. This is the oldest musical instrument in the world that we know of anyway, about 35,000 years old. So we tend to think about those people as sort of, dragging their knuckles, kind of, very poorly educated, not much cognitive thought. I mean, this is a very nicely designed food elk animal. So they were doing things with art and with music that we probably don't have much record of now because a lot of it was done either with wood or hides or things, something like that. This is the Chebec Cave, and apparently they've created. I want to go there. They've created an analog of it where you can actually go visit. You can't get into the original cave. But there are all kinds of wonderful stuff they put on the cave that you can find. Some of it's animals. They tend to have bison, antelope, mammoths. These are, they're illustrating what they were actually having to deal with day to day. Now, why there's so many of these, it's not known. But if you go to other parts of the cave, there's this stuff. Now, that's obviously not an animal. Most people that look at these caves are interested in this part, and I find it beautiful, but it's representative, but it's obviously symbolic thought. So they were able to take, that's an antelope, and here's the way I would see it on the wall, right? And it's really beautifully done. But what is this? And if you look at this really closely, there's actually a hand in there. And what they would do is they put their hand against the wall, and they would blow the ochre against it. Right there. I don't know if you can see it very well from the back. It's not a great representation. But anyway, so the other cool part is there's 190 intact bear skeletons in this. 190 of them. So can you imagine you're in the cave with that? So it's not clear whether they would sometimes it'd be the bear, sometimes it would be the humans, or whether they actually shared it in different parts of the cave, or whether they used the narrowing in some of the caves to do it. But anyway, it's actually, these cave bears don't exist anymore. But you can imagine it was literally probably 14 to 16 feet high. So you can imagine, the bears now are lethal, and this one would be twice as big as most of the bears we see. So around 15 to 25,000 years ago, we start to see human representations. There's another hand for you. And that was Spain and France. If you want to go visit and just look at caves, that's the best place. All right. So I told you I like the pictures, but I like the symbols more. So I like to think about what were these symbols? What were they using for? If you go to, this is 32 different caves in Europe, they all have the similar symbols. So were these religious, or were they keeping track of something? And they're fascinating. They have the little hashtag stuff, but they have all sorts of other different things. There's a little hashtag right there. It's very common to see what looks like either a fern or a tree, or possibly an arrow. If you think about the back part of an arrow, you would have that sort of that shape. Some of the others, who knows? This lady, she spent 2 years crawling around all the caves, well, not all of them, 32 of them in Europe, and came up with a database of all these things and put them together. So keep your eyes on this lady. There's a really good TED Talk that she does that I would recommend. It's just, if you go onto YouTube, that's her. And I guess the slides will be up on the website.
Yes.
Okay. So that was kind of the world tour of genetics, the interaction of language, of art, and we talked a little bit about weather. You know, as the glaciation came down, the people were pushed down with it. And as the glaciation receded, they actually went up with it. So that has to do with some of the migration patterns. But recently in medicine, we've started to really examine what we're using race for. So you've probably all gone in the hospital or clinic, and they've asked you what race you are. So that's always self-volunteered, right? So you tell them you're Caucasian, you're African American, or you're Hispanic, or whatever. But what does that really mean? And I think the joke there was about, it turns out that you're my father or something, but in terms of trying to decide what your genetics are, the genetics like the 23andMe and stuff, you start to see that there's lots of people that are mixed up all over time, ways, different races, etc. So we might identify the one that we think we most are. Like I answer white, but you know, is that really me? So you probably all have had spirometry in here. We use normal values to decide whether spirometry is abnormal or normal. And we also do, we use race in those calculations. So what we started to do is try to figure out if race belongs in that calculation. So this is kind of the, this is a spirometer. Actually, this is one of the oldest spirometers here. Hopefully, some of you are old enough, you might have seen an old spirometer like this. But when you blow into it and the little canister would go up. You guys remember that? Anyway, so they're all digital now. But the old ones, they were in water and they went up. And they actually inscribed as they went up the volume. And we take that sheet off and we actually do the spirometer. Can't show me. So this guy Hutchinson, he was a physician. His dad was a coal merchant. And you know, if you any place in the Midwest United States, you know about black lung. That's coal in the lungs. So he was kind of interested in the effect of different occupations on the lung. And he also worked briefly for a life insurance. They call it assurance back there. We call it insurance. But essentially, you're betting the company that you're going to die, and the company's betting you're going to live. And they get to keep your money if you live. It comes to your family if you die. But you still don't benefit from that. You're either dead or you take a bunch of money or nothing. But what he did was he tried to use the spirometer to try to decide who should get insurance or not, from the company's point of view, not from the patient's point of view. And he also worked in Brompton Hospital, which is one of the premier tuberculosis hospitals in England in 1850, and realizing they didn't know anything really about tuberculosis in 1850 other than people sort of wasted away and died. But he used the word spirometer. Spirare in Italian means to breathe, and meter means to measure, so it's a breathing meter, which makes sense, right? But it sounds better as spirometer. So he was the first person to actually make these graphs and to use statistical analysis of this. So he took a bunch of people, policemen, people in the military. There was quite a collection of trying to decide who should be in the military. Are they physiologically able to do the things you do at these different professions? And he tabulated this stuff. He also used it to diagnose what's called phthisis, which really just means wasting away. And wasting away back then was a conglomeration of diseases that was called consumption. Consumption meaning wasting away. And a huge percentage of those, at least in England, were tuberculosis. So he thought that if that fall in vital capacity, essentially it's the air you can breathe out. You take a deep breath in and all the way out, that's called your vital capacity. As that goes down, your lifespan may be changing, and or you may have a disease like tuberculosis. That's what he was thinking. So this is what I like. This is the, it says, I now never examine a person for life assurance without trying him on the spirometer and feel persuaded if it's generally used, many lives would be refused, which are now taken. So this is from the healthcare point, or the health insurance point of view, right, or assurance. So this is what we talk about cherry picking, where we say, well, we want the people that are very well in our health plan, because they don't cost very much money. We don't want the sick ones. So that's kind of an evil way to look at it, but that's what he put down. So this is Thomas Jefferson. There's been a lot of talk about Thomas Jefferson and miscegenation with his slaves. He actually talked about the corrosive effect of slavery. He realized it wasn't what they should have been doing. but he was from Virginia, and he really came up with these arguments that African Americans didn't have either biological, moral, or intellectual characteristics that allowed them to be free. So this is the start of sort of the abomination that all men are created equal in the United States. First of all, they didn't mention women, and second of all, they're trying to carve out different races. But he specifically states that the pulmonary apparatus may disable both inspiration and expiration. So he was thinking about this, but not probably in a good way. So it gets much darker with this guy. He was a southern physician, he was a plantation owner, and he basically used the spirometer to document that there was a difference in these groups that was documentable, about 20% difference in lung function. Now, what I'm going to tell you is, you've probably all gone in and have pulmonary function tests. They measure how high you are, right? But if you think about it, where my hips are is important to where my total height is. So let's say I'm 6 feet, but you bring up the hips. That means my thorax is small, right? Which means my lungs are small. Now if you bring my hips down, my thorax is bigger, my lungs are bigger. So we're using race here. Because we change the predicted values based upon Asians and African Americans. We don't change it for Caucasians and Hispanics, which is basically describing what we call anthropomorphic, but it's the characteristics of your body. And we're using race as a characteristic of your body when we should be using the characteristic of your body. Where are your hips? So anyway, then this is the most recent, this is the American Thoracic Society 2005 Conti Diary. Now the reason this is important is, let's say these two gentlemen worked in a mine, asbestos mine, and they're claiming that their lungs were damaged, but they probably were. But the white male has 4 liters of his FEV1, so that's the forced exit volume in 1 second. Predicted is 5 liters, so he's 80% predicted, which actually is pretty normal. But let's just say that that's compensated. So the black male also has 4 liters, predicted 5, but because of this ATS criteria, you reduce the predicted by 15%. That means his predicted is 4.25. His FEV1% predicted is 94%, and he doesn't get compensated. Same person, same exact measurement, different outcome in terms of compensation. So that makes no sense, right? So as I told you, we measure standing height usually. We should be measuring sitting height at the same time. And I don't know if when you were a kid, you had one of those little plastic sheets where you could take off the skin and the bones and the blood vessels and all that and the organs. I loved that when I was a kid. So if any of your kids, I don't even know if they have them anymore, I guess they're all probably digital. But anyway, that's when I pretty much knew I needed to get into medicine. So just to finish here, I know we're getting close. This group looked in, Bob Wise is one of the best pulmonologists on the East Coast. He's actually at Johns Hopkins. He tried to look at what are the differences between the different groups. And so he actually found that about 50% of the difference is the sitting height and the body mass index. So imagine if your weight is distributed on your legs versus your chest, that you're going to have different lung volumes. That's okay. But we also associate race with socioeconomic status, which isn't necessarily the right thing to do either. But that was a much smaller portion of this entire difference between these two groups, African Americans and Caucasians. But it's there, which means that your lungs are, the product of all the things you've been exposed to, right? So you've been exposed to air pollution, you've been exposed, maybe there's a freeway next to your house, maybe they've done construction, maybe the oil refinery in Torrance blew up, whatever. There's been a lot of stuff you're exposed to. So your lung function, if I try to relate that to your race, that doesn't make any sense. If I relate it to you as an individual, I can see the differences. So socioeconomic status has to do with educational level, obviously financial income, but it has a lot of things that involve it. So what we're realizing is that's actually much more important part of the whole thing. So this is the U.S. Census data in 2020. There was such a discussion about the census and doing it during COVID and everything else. So unfortunately, the numbers are still, we're a very ethnically diverse country, which actually should be a real strength for us, but we've found ways to make it a real weakness. But In California, the rates of Hispanics are much higher. But these are the groups that you see, and the races percent-wise, what we call races, probably makes no sense. So for instance, if I just take people that call themselves African Americans, obviously a large group of that comes from Africa even today, but it's come over time in slave trade and other things. Some of those went through the Caribbean, some came directly from Central and South America, and there's admixtures of race. So if somebody calls himself African American, that may or may not really describe their origin, even though we're using the word African. So this is an example. This is a study where they actually did full genomes on people. And so these are people that describe themselves as Mexican American. So you can see the Native American, which is blue, is this big portion. So most of those people that are identifying as African American are truly DNA from that area. But look at this. This is European. And then this is African. Those are genes from different parts of the world. So even somebody that identifies themselves as African American might have 20% of African genes, might have 25 or 40% of Caucasian genes. So that's very mixed up. This is Puerto Ricans. You can see that there's still Native American in there. There is European, and there also is African, up to almost 75%. So race doesn't really make a lot of sense. It doesn't make any sense in Los Angeles for sure. We have so many mixed race people that it's a good thing, but it makes poorly function when they ask you what your race is. You only have a few choices. You can't say I'm 25% this, 50% that. But eventually, that's what we will do because that tells you a lot about the anthropomorphic part of the body. Now, this is another thing that's really controversial these days. But this is saying, race is basically ingrained into a lot of the structures in the United States. Now, I'm not going to get into discussion in detail, but I want you to think about it because there are a lot of things I think we can do better. I think medicine is trying to, do a self-examination, try to do things better. It causes a lot of discussions that are very uncomfortable. But on the other hand, I think if we don't talk about it, we don't realize that we're more the same than different. We won't get by this. And so, does racism exist? I believe it does, and it has been institutionalized in some areas. So, I'm going to skip that. But that was a CTS. But this, Neil deGrasse is one of these guys that looks up into the heavens. He says, when I pause and reflect on our expanding universe, and he talks about the galaxies and time and space. But basically he says, sometimes I forget that I'm kind of people walk on the earth without food or shelter. The children disproportionately represented them. Sometimes I forget that powerful people rarely do all they can to help them. So I think that's really an important thing to think about is that there's a lot of things we can do better on Earth. It's great to look up at the stars, and there's a lot of companies that are putting people out there now, but including William Shatner, for that. So you folks remember Star Trek. But I think that we need to turn our telescope back on Earth and do a better job. Do a better job, actually loving each other, not hating each other, and also realizing that we're the same. The answer is, when did you leave Africa, not if you left Africa. So I left a little bit longer, a little bit further away than some other people, but we're all African, and our differences are wonderful. They're wonderful complexity, language and culture and religion, and that's a wonderful thing. It's not a bad thing. They're not taking things away from you. They're showing you other ways of doing things. And humans have been great at that for hundreds of thousands of years, learning how to do things inside of their environment. So I'm going to quit there. I'm happy to take any questions. I know that's a lot to think about, but literally this has all come up since I was in med school. I figure that you folks don't do a lot of biology. It's probably a good thing to hear. You may not believe all this, and sometimes really research changes what we think about stuff. But this is the current thought about our origins, our DNA. And that first sequence of DNA has changed anthropology completely. No longer do we just kind of look at the shape of the skull and try to make some decisions. Now we have genetics that are really to back it up. So I'll quit there. Thank you for letting me come.